Develop fluency in dividing decimals. On the right page, TJ? You're on the right page? Peyton.
Will any of these be negative? Like the numbers?
Yeah. We'll eventually get a negative. Not in the examples, but when we do the alphabet challenge. Oh no! I was nice today. You don't have negatives. So these are all good. They're all same. Yeah, okay. Maybe I'll change that for next year. You guys got lucky. So I'm well aware that this is a like 5th grade standard. Maybe you introed it in 4th grade if you were advanced, and you should know how to divide decimals. If you don't, today's our day to kind of catch up. You'll need this skill in the 7th and 8th grade. When you have dividing and long division, there is two common blunders that 7th and 8th graders make. One is setting up the division problem. The other is moving the decimal. And when you have this type of problem, it looks like a fraction. It really means divide. And here's how I remember how to set it up. If you are, did I mention if you're on top of society last week? Okay, so if you're on top of society, you're rich, you got the newest Tesla, you got a mansion, 8-bed, 5-bath, you got a pool in the back. 46.8 is that guy, and he gets to have a nice house. We're going to build him the house. He's on top of society, so he gets a division house. Look at him go. Okay, so he is the top of society. If you're on the bottom of society, unfortunately, 7.2 made some poor choices in 7th grade, didn't pay attention in math class, maybe punched his friend in the face who was saying not, and was just annoyed like all the time. So he didn't really learn, and he is out on the streets. So he doesn't get a house. That's how you set it up. Not at me if you like are, this is coming back to us. Yeah, I could kind of remember a little bit. Did you do this in 6th grade? Okay, hopefully. So this is your setup. Now, in ancient Egypt, I wasn't there. I was born a little bit after that. The Egyptians like saw this mathematical thing and they wanted to divide. And they came up with this whole process for long division and like moving place values. But when they got to decimals and not whole numbers, it got kind of weird. Because when you divided a 7.2 and a 46.8 in the same way that you do a whole number, it just messes up the entire thing. So what they did was they somehow found out that I wasn't quite there at that point. I was born like a few years after. They found out that if you moved this decimal place 1 over, and you followed that same amount of patterns inside the house, it would actually make 2 whole numbers. And then you could divide it just like long division, and you'd get a great answer. I want you guys not just to know that you're moving decimals, but I want you to know why you're doing it. So when you move 7.2 over to make 72, you're really multiplying by what? You're multiplying by 10. So if you have your calculator and you put 7.2, you multiply 10 in there, it's going to make a whole number. If you have 46.8 and multiply by 10, it's going to make a whole number. That moves your decimal. It's really just multiplying the whole thing by 10, which gives you your whole number. But Mr. Macti has a weird story for you to remember how to divide by decimals. Here's your funny story for the day. So it's not really funny, it's just a story. It's partially true. I had a dog named Sully a year ago. He was a ginormous beast of an animal. He was a Great Pyrenees. He was giant, he was fluffy. He was more like a polar bear. We got him to fight our black bears. It didn't happen because he was kind of too nice. But he did hate cats. And we had a cat called Mittens. And when Sully, who was outside most of the time, and Sully is this decimal point here. When Sully would see a cat, and our cat Mittens would like to kind of taunt him at the window. Here's your window right here. And Sully would look at the cat, and he would just charge. And he's like, oh, I want the cat. He wouldn't do anything ferocious. He just wanted to like play with it and be kind to it. And he would move over, and he would hit the window. He was so tall that his like face would go up to the window and just hit it. And the cat would be like perched right on the couch and just like looking at him. But cats like to taunt dogs. They're like pretty independent, kind of mean. And so here's the cat mittens. Well, the cat moves away the same exact time or amount of space that Sully did. So mittens moved over 1 because Sully moved over 1. That is your new division problem, and we're going to reset it up without any decimals, and it will look like this. Did you guys do decimals moving in 6th grade? Okay, so that hopefully that's not like too new. If it is, now you have a story to lodge into your brain. So Solely moved over. If you haven't already written it, write it like this. Mittens moved over, and we have a whole new division problem. Okay. There's your division problem. There's your decimal. And Mittens would also find a way to sneak out and then go up on the house, on the roof, and just kind of taunt Solely. And so Mittens is also up here. She did not clone herself, but it looks like that in the problem. Okay, let's divide. So 72 can't fit into 46. 72 has to fit into 468. Anybody have a guess? When you have division problems like this, really the best way is to guess and check and develop strategies around that. Mackenzie? Okay, and did you have a strategy, Mackenzie, of how you started with that number?
Well, I actually started with 8. I did 72 times 8, and then I got like a really big number.
Let's check. So let's guess and check with 72 times 8 first. 8 times 2 is 16. 7 times 8 is 56. Plus 1 is 57. That is bigger than 468, so we're not using that one. Mackenzie, let's go down to 7 and try that. Okay, so 72 times 7 should work. 7 times 2 is 14. 7 times 7 is 49 plus 1 is 50. Did 7 work? Okay, let's try again. What should we check instead of 7? Maybe 6 or 5, Claire? What do you want to use? Okay. Let's try 72 times 6. Whoopsies. 2 times 6 is 12. 7 times 6 is 42. Plus 1 is 43. That one fits in nicely. So we'll have some remainder, but we'll start there. I'm going to draw a line for my scratch work. Subtracting this, you get 6 and 3 and a 0. Okay, we have 36 left over. What do I do with that with long division? Kira. Bentley. Kira Bentley. Okay, 72 goes into 360. Is this going to work out? How many times, Kira Lind? 5 times? Is it even? No? Maybe? Let's try. 7 times 2 is 10. 5 times 2 is 10. 5 times 7 is 35. Plus 1 is 36. That works out. Yay. And we are going to... What did I mess up? Ashlyn. Yes, my 6 multiplied to get into 468 right there. 6.5 is your answer. You can circle it. Okay, let's go to example 2. We got 3 more. I might let you do partner work for one of them. When you have a slash, this also means the same thing as 28.98 divided by 8.4. So same thing. You're going to set up 28.98 in the house, 8.4 outside. How many times does Sully move to chase the cats? Peyton.
Once.
Do I move the inside once or twice?
I think 1.
The cat only moves over the same amount as the dog. Like Mittens is pretty lazy too, and she will not move more than she needs to. Moving one place is sufficient to ease her nerves. She jumps on the house, taunts Sully, and there's your new division problem. 84 is outside, 289.8 is inside. Can I have a decimal inside the house? It's okay, sure. We just want the outside to have a whole number. Solve this. Yeah, then I want you to do the rest on your own. 84 can't go into 28. It could fit into 289. Raise your hand when you have an estimate. If you're stuck on the guessing and checking part and you're starting to go way off, look at the first digit with the first two. So 8 goes into 28. How many times? Peyton. Jada. Okay, and 8 times 3 is 24. Is that close to 28? That's a trick that you can use. So 8 times 3 is 24. That's close to 28. Let's try it. 3 times 4 is 12. Yeah, I want to set it up over here. 84 times 3. 8 times 3 is 24, plus 1 is 25. Okay. That works, and we'll have some remainder. Anyone subtract that already? What remainder do I get, Liliana? Wait. What did we get? 252?
Oh, I messed up the number.
Okay. I think it was 37, right?
Yeah.
Okay. Bring down your 8. 378. Can 84 fit into that? I'm thinking about 37. 8 times what is close to 37? That would be... It's not going to be 5. That's over. Frankie, how much? Let's try 4. 84 times 4 might fit in. 4 times 4 is 16. 4 times 4 is 32. Plus 1 is 33. Oh, and there's more left over. Darn. Where did I put the 3? I forgot that again, Ashlyn. Is it above the 8 or the 9? Why is it above the 9? I was trying to fit a number that fit into 289, right? So it goes above the last digit. Then it was a 4, and then we subtract. Can 84 fit into 42? It can't, so you make a 0. Bring down a filler 0. Can 84 fit into 420? Hopefully this is going to be even, otherwise I might end up just throwing a chair out the window. Yes. Yeah, Mackenzie. Sure, yeah. 5 times. I would guess that too, because 8 times 5 is 40. 5 times, or 4 times 5 is 20. 5 times 4 is 40, plus 2 is 42. Yay, it's even. No chairs are being thrown. Good thing. And that was a 5 above it. 3.405 is your answer. I'm going to have you set up example 3 and 4, and then we're going to pause and go to a challenge. 8 is on top, so it gets a house. 0.5 is on the outside. Oshu, how many times do I move the decimal? Okay, but there's no decimal by the 8. What do I do? Abby? Yeah, we can put a decimal here, because 8 is really the same as 8.0. And that works. Move the decimal over once, and you end up with 80 divided by 5. Don't divide it, just set it up. Kira, who goes in the house for example 4? Sorry, Murphy. You were right. The 40.8. Oh. For example 4. 4, yeah. Okay. There are no decimals with the 2. Do I have to move a decimal at all? Tessa, what do you think? Why not? Yeah, and Soli escaped and went just wandering for miles and miles. The cat's chilling and loving life. The cat doesn't have to move because Soli is not there to interrogate and not interrogate, antagonize. That's the word. Yeah, so that stays the same. You don't move it. 2 special cases you might see. Take out scratch paper. Anyone not have line paper? If you want to do examples for while we're waiting, you can finish that. You're going to set up scratch paper like this. Put today's classwork at the very top. It is 1-7 classwork. There we go. 1-7 classwork. And that's what it looks like. Put your name on your scratch work. And then you're going to look at this page. Don't look at the answers. Look at the actual challenge. So you're going to start with A. You're going to label it A, not 1. Label it A. And then you're going to write the problem. The problem is 9.8 divided by 0.2. It's a slash, but it's the same thing as that. You can write it either way, whatever makes you feel better. You're going to then set up the house. You're going to move the decimal and rewrite it so it's nice and neat and it doesn't have any decimals on the outside. You're then going to solve the problem, circle your answer, and then draw a line, and then do B. Your job in the next 10 minutes is to do as many as you possibly can. I think our record last year, we had 15.